In modern air combat today, survival comes down to three non-negotiable metrics: staying airborne longer than the adversary, seeing threats from further away, and processing data faster than the enemy can react. India's original Tejas Mk2 is a highly capable machine, but it operates strictly within the physical limits of its lightweight classification. This data visualization maps out those specific constraints against India's massive geographical borders. The Mk2 caps out at roughly 57 minutes of combat patrol time. It carries a maximum of 3.5 tons of payload, and it relies on the older 84 kilonewton GE F404 engine. To secure domestic airspace and cut reliance on foreign defense imports, incremental upgrades would not be enough. The entire aircraft required a complete ground-up scaling. That engineering overhaul produced the Tejas Mk2. By significantly expanding its physical dimensions and operational capabilities, the platform was reclassified into a medium-weight fighter. Looking at this data table, the new airframe is 1.35 meters longer, creating room for 11 hardpoints and nearly doubling payload capacity to 6.5 tons. Comparing the silhouettes, the larger Mk2 houses the new General Electric engine, delivering 98 kilonewtons of thrust. Engineers also added close-coupled canards, small forward wings positioned right behind the cockpit. Combined with the heavier thrust, these canards allow the jet to maintain high energy and sharp agility during tight, high-speed maneuvers. This spec sheet highlights the resulting endurance gains. The expanded internal fuel tanks push the combat radius to over 1,000 kilometers, allowing the aircraft to maintain combat patrols for up to 120 minutes. By doubling the payload and doubling the time on station, the aircraft transitions from a short-range point defense interceptor into a heavy offensive platform built for deep penetration power projection. The physical expansion is matched by a complete digital overhaul. Legacy fighter cockpits often force pilots to split their attention across a cluttered array of small screens, analog dials, and disjointed sensor feeds, leading to high cognitive fatigue. The Mk2 solves this with a massive 20 by 8-inch touch-enabled large area display. This unified interface automatically merges flight parameters, navigation data, and weapon targeting onto a single screen. By streamlining the information, the pilot's mental workload drops, allowing for faster, split-second tactical decisions. Running behind that screen is a software architecture known as Open Architecture Avionics. This diagram shows how the system places a strict firewall between the basic flight controls and the combat mission software. Because those computing layers are separated, the Indian Air Force will be able to plug in new, domestically built missiles or deploy rapid software updates in the future without ever needing to touch or recertify the jet's core flying mechanics. That rapid integration is crucial for the Mk2's primary weapon, the Astra Mk3 Beyond Visual Range missile. The Astra Mk3 uses solid-fuel ducted ramjet technology. Unlike a standard rocket motor that glides and loses speed, the ramjet maintains continuous thrust. Arriving with that sustained energy creates an enormous no-escape zone, a specific radius where an enemy physically cannot outmaneuver the weapon. Guiding a missile across those extreme distances requires an incredibly powerful sensor. The Mk2 uses the indigenous ATOM active electronically scanned array radar to track hostile targets through heavy electronic jamming. But the true reach of the Mk2 relies on a networked kill chain. A Netra surveillance plane flying at high altitude can spot an enemy jet hundreds of kilometers away and instantly beam those exact coordinates directly to the Tejas Mk2 via a secure data link. This setup creates a lock-on after launch scenario. The pilot can fire the Astra Mk3 using surveillance data, immediately bank away, and exit the combat zone before enemy radar even registers a threat. The lethality of the platform comes from its ability to act as a silent, heavily armed node within this massive airborne data network. Combining a 98 kilonewton engine, a smart cockpit, and ramjet-powered networked weaponry elevates the Tejas Mk2 into the same technological tier as the world's premier 4.5 generation fighters. This platform is designed to be the backbone of India's long-term defense strategy, replacing depleting legacy fleets with a system that can continuously evolve. By manufacturing the airframe, the multi-layered mission computers, the ASAR radar, and eventually large portions of the GE engines entirely on domestic soil, India is breaking its historic reliance on foreign military imports. With its advanced networked ecosystem and lethal air-breathing missiles, How do you think the Tejas Mk2 will reshape the balance of power in the skies of South Asia? Let us know in the comments below.